Hello, I'm Muhamed
I'm Marcy Anderson.
and we were mentored under Dr. Christian Rosier and Megan Ryan for the summer engagement in cyber undergraduate research experiences, Secure, and we were the second project for IoT security through formal methods. Our main problem that we were looking at is IoT devices, and IoT devices are Internet of Things, and they are becoming incredibly important in the average household. We use it all the time. For example, like a Google Alexa or like a thermostat, smart cameras, door locks, anything. That's becoming very popular and normal in people's houses. However, the problem to that is that most of them don't come immediately, like when they're being built they don't have security built in within them. So we have to get out and actually find software online to use because some of that data is being leaked out. And our solution to that is to create formal methods immediately in the IoT device to create a security framework that IoT developers can use in the future. IoT devices that we looked at through our research were three different ones. We looked at door locks, security cameras, and thermostats. For door locks, we looked through two different ones. Those IoT devices usually have an actuator, which is a motor within the lock to open and close it. And that will send information to a hub or an app on your phone or a server. And it will send that information back and forth, talking to each other without any human interaction, which is what an IoT device is. And it will send information to an app. Most of the ones are Bluetooth. That's what the user connection based off from, not Wi-Fi. So it will send information from that door lock, the sensor, or the motor, actually, my bad, to the app to work. The next thing we looked at is the security camera. And the cameras will have the sensor and it'll have a software built in within it, which will look at the face. And if it doesn't recognize that person, it will send information to the app or the phone via Wi-Fi. So you can get it immediately on your phone. It'll just contact back and forth from the app or the hub to that device, the sensor. The next thing you looked at is thermostats, and they use HVAC, which is heating, cooling, and air conditioning systems that are all wired into the house. So it's pretty easy to have a sensor right there. And it will send information from that to a hub, just like the door lock and security cameras, to a hub on your phone or an app. And this one will be based off Wi-Fi, just like security cameras, not door locks. And with all this when we found all this out in the very beginning, we started to look at SV Comp, which is a competition we'll base off our solution on from.
So SVComp delves a lot into formal methods and verification tools which other teams have built. Formal verification tools are a very intense way of looking at a section of code and deciding kind of whether or not it can cause a certain error. So it's very extensive algorithmic testing of these things. So SVComp holds this competition every year. It runs tasks with C and Java. We were focusing on the C tasks because that's a more common programming language for IoT devices. So some of its categories are like memory safety and reach safety. So things that are concerns with IoT devices and that could cause leaks, and your personal data leaking out of your Alexa is not a good thing. So these are things we want to kind of stop before they even start. And then to test these tasks, they run them through a gamut, to test the tools, they run them through a gamut of tasks designed to test these certain categories. And then there's a witness validator for each task to say whether or not the tool should say, yes, this task won't cause an error, or this task could cause an error. And so SVComp really values accuracy. So you get like 1 or 2 points if you correctly say this will be true or this will be false. And I think 0 points if it's unknown, but it's significantly higher negative points if you incorrectly say this will be true, like this is correct, this is safe if it is not, or this isn't safe if it is. So SVComp fits into our research process kind of everything is kind of building toward a tool competition of our own to see which of these tools is most secure. So we took the security related categories in SV Comp and the security related tasks, and looked at the tools performance on those. And then we looked at open source IoT projects for the IoT devices that Muhamed described, and took their code and made them into C modules and verification tasks, looking at certain specifications and security guidelines that we think that are commonly used or commonly not used, but should be used when looking at the security of an IoT device, such as input validation. We took these and made tasks out of those. And we are going to run our own tool competition to see which of these tools right now is doing the best at measuring security or could be doing the best at measuring the security of an IoT device. And then also we're going to submit the tasks that we make to SBComp so that in the future, more tools will be based around security. Different tools can make different people can make tools fit more with security guidelines so that we have we're furthering the formal verification tool knowledge of security.
And to evaluate these tasks that we're going to be making, we're going to use a special tool that SVComp uses, which is called BenchExec, and we'll use that to measure the CPU's time. And with that information, we can see which tool takes the longest to run through a different set of tasks, and whichever one is the most efficient or has the less time CPU time usage, then we will use that tool specifically to look at our devices so it can be the most efficient. We'll use the accuracy of the tools verification software by using their different tasks. So each category will have their own tasks built within. And we've been focusing a lot on the memory aspects of these tasks because they're more security oriented. We will base our scores off of the SVComp system, which punishes inaccuracy, which is what Marcy explained before. And overall, we've created a bunch of tasks and we've tested our tools. We don't have our own competition environment set up yet, just like how SVComp has it, so we can test our own security, but we're getting there. It will take just a bit more time. This project is currently not complete, but it will be continuing on to the next semester, and hopefully we can finish it by that time. Thank you.
Thank you.